Let's take a look at putting together some of these radical function transformations. As you can see here, when we take a look at this first function of f of x equals the square root of x plus 3, this plus 3 is on the inside. That means that it's a horizontal shift, and the plus means opposite, so it's actually going to go left 3. Now remember, we go back to chapters 2 and 3 when we wrote our rules. Horizontal affects the x, so that means x left 3 is minus 3, and y is not being affected because there is no other transformation. So as you recall, with this original one, our f of x's are 0, 1, 1.4, 1.7, and 2. If we shift the x minus 3, that means x will be negative 3, negative 2, negative 1, 0, and 1, with our y still being 0, 1, 1.4, 1.7, and 2. So if we go to graph this, we end up getting negative 3, 0, negative 2, 1, negative 1, 1.4, 0, 1.7, and 1, 2. So as you can see, it's a horizontal shift to the left 3. Our domains for, if you recall from the last video, our domains of the parent function are x such that x is greater than or equal to 0, and y such that y is greater than or equal to 0. And when we go to our parent function, our x has shifted such that now x is greater than or equal to negative 3, because that's the furthest point over at which it goes. And y is still y such that y is greater than or equal to 0. Moving on to another example. We've got 2 times the square root of x plus 1. That 2 tells us we have a vertical stretch, and it is a factor times 2. And this plus 1 tells me we have a vertical shift up 1. So when we write our rule, we don't have anything affecting the x, so x stays x. Stretch times 2 says we're going to take y multiplied by 2, and then up 1 is plus 1. So when we write our old ones, 0, 1, 1.4, 1.7, and 2, x's stay the same, 0, 1, 2, 3, 4. Our y's, we multiply by 2 and then up 1. 0 times 2 is 0, plus 1 is 1. 1 times 2 is 2, plus 1 is 3. 1.4 times 2 is 2.8, plus 1 is 3.8. 1.7 times 2 is 3.4, plus 1 is 4.4. And 2 times 2 is 4, plus 1 is 5. When we go ahead and graph this, we have 0, 1, 1, 3, 2, 3.8, 3, 4.4, and 4, 5. And then when we take a look at our domain and range, once again, domain and range of the parent function is y and x both greater than or equal to 0. For the domain and range of the new function, x is still such that x is going to be greater than or equal to 0, and y is going to be such that y is greater than or equal to 1, because the lowest point that it goes is positive 1. Moving on to the third example. I see here that I have a negative, which it's on the outside, so it's a vertical reflection. And then the minus 4 on the inside is a horizontal shift, and minus 4 tells me I'm actually going to go the opposite and go right 4. When I write my rule, horizontal shift right 4 means I'm going to take x and add 4 to it. Vertical reflection means I'm going to take my y's and make them the opposite. So I have my 0, 1, 1.4, 1.7, and 2. And so my new x's are going to go up 4. So I have 4, 5, 6, 7, 8. And my y's are going to go negative, which means 0, -1, -1.4, -1.7, and -2. Going ahead and graphing these. We have 4, 0, 5, -1, 6, -1.4, 7, -1.7, and 8, -2. So when we write our domain and range for that new function, x is such that x is greater than or equal to 4, and y is such that it is now less than or equal to 0 because it all goes below the x-axis. Trying our final transformations problem, we have f of x equals the square root of 2x minus 3. That tells me that this 2 is a horizontal, and because it is bigger than 1, this is actually a compression, and that is multiplied by the reciprocal of that, which is 1/2. And then the minus 3 tells me I have a vertical shift, and it is down 3. So the horizontal compression tells me I'm going to take all my x's and take half of them, and all my y's I'm going to subtract 3. So when I fill in my table, my original ones of 0, 1, 1.4, 1.7, and 2, now I'm going to take half of all my x values. So I still have 0, 0.5, 1, 1.5, and 2. For my y values, I have -3, -2, -1.6, -1.3, and -1. Going ahead and plotting these, 0, -3, 1/2, -2, 1, -1.6, 1.5, -1.3, and -2, -1. So this goes this way. It looks the same, but it gets a lot more crunched together. And then when we take a look at the domain and range of this new function, it's still all x such that x is greater than or equal to 0, because 0 is still the smallest starting point. For the range, it's going to be y such that y is greater than or equal to -3.